Welcome back. In this section, we're going to be looking at the multiplication principle, which is one of our fundamental principles that we use for counting. For this principle, we're thinking about a scenario where we've got some sort of task that we need to do, and that task can be broken down into some smaller activities that are either done back to back or maybe done simultaneously. It doesn't really matter. So an example of that might be you go into a coffee shop and then they'll ask you, did you want coffee or tea? And then once you make your choice, then they'll ask you, did you want a small, medium, or large? And then you will give your answer to that as well. So the big task of ordering something at the coffee shop really has two activities. It's the am I having coffee or tea? And then am I ordering something that's a small, medium, or large? The multiplication principle says, well, if you wanted to know how many possibilities you have when you go to that coffee shop, you would say, well, there are two different ways that you could order a coffee or a tea. You have two options there. And for size, small, medium, or large, there's three options. So you should have 2 times 3. You should have 6 possible things you could order at this coffee shop. The good thing to note for this, the couple of things. Number one, it doesn't stop at only two activities. If you had more than two activities, so if the coffee shop, they asked a follow-up question, do you want milk? Yes or no? Did you want sugar? Yes or no? So if they asked further questions, then we can find out how many ways there are there for me to do my order just by multiplying together all the ways there are to do those individual activities. The thing to also note here is it doesn't matter whether we're doing the activities in a particular order or not. So at this coffee shop, I could tell them what size I want first and then tell them afterwards whether I want coffee or tea. It doesn't make a difference. There would still be either 2 times 3 or 3 times 2. There would be 6 options for what I could order at that coffee shop. Okay, so let's get started with some examples. For this first example, before we answer it, we just have to sort of point out some details about it because, of course, with any kind of counting question, a slight change to the scenario can have a big impact in how we think about it. So to begin with, at this bakery, when I say that there are 12 pies and 10 cakes, it's not that I've got 12 flavors of pie and I've got multiples. So this isn't like going to a bakery where there's 7 pumpkin pies on the shelf and 8 apple pies. I have 12 different pies, one of each flavor, and that's it. This store has only 12 pies in it. Once they've sold those 12 things, that's it. They have no more pies for sale that day. And same thing for the cakes. There's 10 of them, and they are all different from each other. So 10 different flavors of cake, one of each, and 12 different flavors of pie, one of each. And my friend and I, we're going to walk into this store and we're going to place our order. So when I'm thinking about this is an activity, or this is a task where I've got two little activities. I need to select something and my friend needs to select something. And the multiplication principle says it doesn't really matter what order we do things in. So it doesn't really matter if I go first and my friend goes next, or my friend goes first and I go next. So I'll go first. So for me, when I first start off, I'm supposed to be ordering a cake. So when I go to the counter, I will have 10 choices available. Now, here's what we need to keep in mind. Of course, once I've taken that cake, purchased it, and walked out the door, my friend won't have 10 options for cakes anymore. They'll only have 9 options remaining. So, whether I go first, I have 10 options, then my friend has 9. That means that'll give us 90 possibilities in total. And of course, the reverse would have given us the same. If my friend went first, then my friend would have had 10 choices, and then if I went second, I would only have 9 choices, but that would still give us 90 ways for us to make our order. So it doesn't really matter who goes first or who goes second. In fact, we could sort of even imagine it simultaneously. There's 2 cashiers and we both shouting out our orders. We can't order the same thing, but we can both place our orders. Okay, let's do the second one. We're ordering a pie. So again, I'm going to have that broken down into 2 little tasks. I'm going to order and then my friend is going to order and we're both ordering pies. So 12 choices for me when I walk into the store, and then after I've ordered, my friend will only have 11 choices. So there's 132 possible ways for us to make our order there. And then one last. I'm going to select a cake, and my friend is going to select a pie. So there's going to be one activity. So me selecting a cake, and then there's going to be my friend who's going to select a pie. So I'm going to start off. I have 10 choices for my cake. And it doesn't really matter what I pick. That's not going to affect the number of pies. There's still going to be 12 pies in the store. So it looks like there should be 120 ways for us to make our order at this pie and cake store. Okay, let's do another one. Example 2. Here we are electing members to a committee. So we are selecting a committee where there's going to be a president, a vice president, and a secretary. And we've got a little restriction here. No person can hold more than one position. So we are going to pick one person for each role. So that's good to know. And we cannot have the same person doing more than one thing. So if somebody is elected to be president, they cannot also be secretary. So in a way, it's kind of similar to our cakes and pies, where after I pick a cake, that affects the number of cakes we'll have to choose from. Similarly here, once I've selected somebody to be president, that's going to affect how many people I have left to work with for who could be vice president or secretary. Now here there's 3 little activities. We have to select a president, select a vice president, select a secretary. And for the first part, for part A, we don't have any restrictions on the selection process, so I could do it in whatever order I'd like. I'll just keep it in the order president, vice president, and secretary. So to begin with, we have 40 people available in this class. Cleo is one of those 40 people. But for this first question, we don't really have to care whether or not Cleo is being elected to anything. So at the very beginning, there would be 40 people available to be president. And then once we picked somebody to be president, we only have 39 people for the rest of the election. So there are only 39 choices for who could be the vice president. And then once we've picked a vice president, now we've used 2 out of the 40 people, which means there's only 38 people left who could run for the position of secretary. So since we're doing these 3 little activities back to back, we're selecting a president, then a vice president, then a secretary. We should have 40 times 39 times 38. We should have 59,280 possible committee selections that we could be making. One thing I just want to point out before we do part B and part C, this part that we did in part A, you might have heard me say that we're doing this with no restrictions. This is all the possible ways that we could select our committee. So for parts B and for part C, where we're putting some restrictions on, Cleo doesn't want to be the vice president in part B. Cleo will be the president in part C. We're going to expect that however many options there are for B should be less than there are for part A, because if we're thinking about in terms of Venn diagrams for just a moment, if we're thinking about the universe being all the possible ways we could select our committee, the universe has 59,280 things in it. If we're thinking about a set of selections where Cleo is not the vice president, that should be smaller than this number because that's putting a restriction on. Okay, one other thing just to get ourselves thinking about this, when we're thinking about the tasks or the activities, I said we could do things in whatever order we'd like. Some orders might be easier. So in the case of restrictions, so for this one, Cleo does not want to be the vice president. Since the restriction is on being the vice president, it might make sense to deal with the vice president part first. So that's my plan. I'm going to actually change things up a little bit. I'm going to first elect for my class the vice president, and then once we've decided that, then we can fill in the other 2 jobs, however. So the second hiring that I can do can be the hiring of a president, and finally the hiring of a secretary. So let's get into this. Cleo does not want to be the vice president. So at the very beginning of things for our first election, we do not have 40 people to choose from. We've only got 39 because there's 39 people who want to be vice president, and there we go. Now, once we've elected our vice president, that person is no longer in the running for anything else. However, Cleo is in the running for president or secretary. So we've lost one person to choose from because we've elected a vice president, but we've also gained a person because Cleo is now back in the running. So if we're thinking how many people are available to be president now, it's 39 again. We had the whole class minus the one person who is now vice president, leaves us with 39 people who could be president. And then now that we've elected a vice president and a president, whether or not that president's Cleo doesn't really matter. Either way, we're going to have 38 people left who could be the secretary. So 57,798 ways for this to happen. One little side note before we go further, part of the reason why maybe dealing with the vice presidency first makes sense would be if we did president first, then vice president, and then secretary. When we fill in the president part, there would be 40 options, but then the question of how many people you have to be vice president, that's not as easy to tell because it would really depend on whether Cleo got selected to be president or not. So that's what I mean by it probably makes more sense when there's a restriction to deal with the restriction first. I do also want to point out we could have used counting the complement for this because if we're thinking about all the committees where Cleo isn't the vice president, we might have said, would it be easier to count all the committees where Cleo is the vice president? We might have been able to use counting the complement to help us out. But I'll leave that for some future tougher questions. I just want to do some more straightforward multiplication principle with these ones. The last one for part C is Cleo desperately wants to be the president, and she is taking that role. Nobody else wants to be the president. So how many ways can we select our committee? So in this case, the restriction is on the presidency. So I'll have that be dealt with first. Vice president and secretary, I'll deal with those last. So at the very beginning for presidency, Cleo is the only one who wants to be president. So how many people do I have to choose from? Only one, just Cleo, that's it. So now I'll fill in the remaining positions. Cleo is now installed as the president of this committee, and so that means there's 39 people left who could be the vice president. And then once we've selected a vice president, there's 38 people who could be the secretary. So 1 times 39 times 38, there are just 1,482 committees where Cleo happens to be the president. All right, one last example. Example 3. So here we are completing a test. This test has got 9 questions. 3 of them are multiple choice. 6 of them are true and false. 3 of them are true and false, and 6 of them are multiple choice. For the multiple choice, the options are A, B, C, and D. So the multiple choice ones, they all have 4 options and 4 options only. So if we're thinking about completing this test, there is the first part, which is what if you have to answer every single question? So if I'm guaranteed that I must write something down, I'm not allowed to leave questions blank, then I basically have 9 little activities, 9 little tasks that are being done back to back. I'll be answering question 1, 2, and 3, those 3 true and false questions. And then I'll go on to the questions 4, 5, 6, 7, 8, and 9, the multiple choice questions. So 4, 5, 6, 7, question 8, and question 9. For the true and false questions, for each question, you would have 2 choices. You could say true or false, true or false, true or false. And for the multiple choice questions, you could say any one of the 4 answers, A, B, C, or D. So for each of those 6 questions, there would be 4 possibilities. So we'd have 2 times 2 times 2, and then 4 times 4 times 4 times 4 times 4 times 4, all that multiplied together. Just to make it more compact, I could write it as a 2 to the 3 times a 4 to the power of 6. And when I run that through my calculator, I get 32,768 ways for you to complete that test. Now, of course, you don't necessarily need to answer all the questions in real life. You could always leave something blank. In fact, you could leave the entire test blank if you wanted to. So now we're going to ask the question, what happens if we don't have to answer everything? What happens if we're allowed to leave questions blank? So it's still going to be 9 little activities because I'm still going to have to think about completing questions 1 through 9. So question 1, 2, 3, 4, 5, 6, 7, 8, and 9. The one thing that's now changed is how many ways there are to complete each one of those activities. Instead of only 2 ways to complete my true and false questions, now I'll have 3 ways, because for question 1, I could say true, I could say false, or I could leave it blank. So 3 options. And same thing for the other 2 true and false questions. You could say true or false or blank, true or false or blank. And then finally, for the multiple choice questions, now instead of 4 options, you've now got 5 options, because you could answer A or B or C or D, or you could just say nothing. So we would have 5 options for each of those 6 multiple choice questions. So you could write that as 3 to the power of 3 times a 5 to the power of 6. And just as a whole number, that turns out to be 421,875. So again, once we don't have restrictions on how we're completing this test, we get more options that are available to us. When we put restrictions on and say you must answer questions, we have less options available for us.